Dr. Mark Changizi here with your Science Moment. Today I'm going to ask, what are ribbons? Ribbons are stranger than you might have thought and are sort of a cognitive counterexample to the way that you carve things up in the world. Now, under normal circumstances, when you're talking about objects in the world, you imagine that there's sort of blobs, which are like a cube, and they'll have sort of three different dimensions, which are roughly similar to each other. You've got X and Y and Z. It could be a blob here as well, or a sphere, but they're all roughly the same. And to the extent that something gets more long, you'll say that it has more one-dimensional features. You'll say it's kind of 1D-ish. And so instead, it might have X and Y as fairly similar, but then let's say have a long Z dimension. And so, or it could just be a tube as well, but just I'm keeping X, Y, and Z here, so it's a long tube. So we say it's more 1D-ish. And of course, 1D never happens in the real world because, in fact, X and Y would be really, really, really tiny. And so in this kind of case, we have X is approximately the same as Y, and they're both much less than Z, whereas over here, we have shapes that are roughly all three dimensions are about the same. Now, sometimes we'll say that something is kind of 2D-ish, like a plate or a flat table or something like that. And in such circumstances, we have let's say a very small X over here that will have a long Y and also a long Z, something like this. So we've got a Z and a Y, and they connect over like this. So in such circumstances like this, you have that X is much less than Y, and Y and Z themselves are about the same. So you have, in some sense, in your cognitive way of thinking about shapes, if something doesn't have much of a shape, you might just say it's a blob, or it's roughly three-dimensional. But if it starts to have 1D-ishness, you'll say, well, this is sort of the 1D-ness moving this way. And to the extent that it pushes towards something that's flatter, you'll say it's more 2D-like. So this is its 2D-ness. And in fact, if you had to put, this is actually Z minus Y, is the more that you move, the bigger that Z gets relative to Y, the more you move this direction, and the bigger that Y gets relative to X, the more that you move up in this direction. So we do have this notion of, even though 1D doesn't exist in the real universe, and 2D doesn't exist in the real universe, we still talk about 1D things, rods and two-dimensional plates and flat objects. But this still leaves open this question about ribbons that we talked about. And the one thing nice about ribbons is that, in terms of this space here, well, ribbons are a case up in this right-hand corner. So in fact, we end up with this nice space here of shapes. And in this corner, we end up with it having X is much smaller than Y, and Y is much smaller than Z. You end up with cases here which are both very 1D in this sense, but also very 2D in this sense. And that's what you have with a simple case like a ribbon. You have something with very thin X, a much longer Y, and then a much, much longer Z. See if it's very thin, like this. Now we have a very fundamentally different kind, a qualitatively different kind of shape. It has the aspects that you expect from 1D, it has the aspects you expect from 2D, but it has both. And this is the world of ribbons in this upper corner over here. So we end up with sort of rods, plates, and down on the left you have sort of blobs, and that covers both cubes and things like this. The nice thing about this space is that we live in a three-dimensional world, and yet you can characterize in this two-dimensional space all of the sort of at the zeroth level of at the zeroth approximation level, the shapes of these kinds of objects in only two dimensions. And so it turns out that I begun some years ago trying to do examinations of the kinds of shapes that you find in nature. And disproportionately, the kinds of shapes that you find in nature tend to be out here in these regions. And you find a lot of ribbons. In fact, there's whole phyla, whole groups of animals that are just as related to one another as we vertebrates are related to ourselves, which are just flat, ribbon-like. They're not like this, they're not like this, they're definitely not like this, they're ribbons. Tubes, all the tubes in our body, all the pipes, all of the vasculature, which we're built out of, are all in the ribbon space. Because what is a pipe after all? A pipe is something with a very thin thickness to its wall, which you could say is X, and then the whole circumference, which in this case would be Y, going all the way around, and then it has some kind of long Z. Okay? So pipes, because pipes are never solid inside, are part of the ribbon case. Much of the world isn't 1D, and it isn't 2D. Much of the world that's interesting biologically and as well as in terms of design and engineering are built out of things in this far corner of this space. And that was your science moment.